Welcome to Shri Learning Academy. Let's simplify the booting process. When you press the power button on your computer, it may look simple from the outside, but internally a well-planned sequence of events begins. This entire sequence is known as the booting process. It explains how your computer goes from a powered-off state to a fully usable system with an operating system running and ready for you. To understand this clearly, imagine your computer as an office building that is completely shut down at night. No lights, no staff, no activity. Pressing the power button is like unlocking the main gate and switching on the electricity. Power starts flowing to the processor, memory, storage devices, and other hardware components. The first active component is not the operating system. Instead, a small program stored permanently inside a chip on the motherboard takes control. This program is stored in ROM and is commonly known as BIOS or in modern systems UEFI. Its main responsibility is to prepare the system to load the operating system. The BIOS or UEFI begins by performing a basic health check of the system. This step is called power on self-test. During this stage, the system checks whether essential hardware like RAM, CPU, keyboard, and display are working properly. If there is a serious issue, the booting process stops right there, often with error messages or beep sounds. Once the hardware check is successful, the system needs to find the operating system. But the operating system is stored on a storage device like a hard disk or SSD. To locate it, the BIOS or UEFI follows a predefined boot order. This order tells the system where to look first, such as the internal disk, a USB drive, or a DVD. Now, this is where concepts like MBR and GPT come into the picture. These are partitioning styles that define how data, including boot information, is organized on a disk. In older traditional systems, disks commonly use something called MBR, which stands for Master Boot Record. The MBR is located in the very first sector of the disk. It contains two important things. First, it stores information about disk partitions. Second, it contains a small piece of executable code known as the bootloader. When the BIOS finds a disk with an MBR, it loads this small bootloader code into memory and hands over control to it. This bootloader then looks for the operating system files and loads the operating system kernel into memory. Think of MBR like a simple map placed at the entrance of a library. It tells where the sections are and also gives basic instructions on how to enter the main area. However, MBR has limitations. It supports only a limited number of partitions and has restrictions on disk size. To overcome these issues, modern systems use GPT, which stands for GUID Partition Table. GPT works closely with UEFI instead of traditional BIOS. Unlike MBR, GPT does not rely on a single small block at the beginning of the disk. Instead, it stores multiple copies of partition information across the disk, making it more reliable and resistant to corruption. In GPT-based systems, there is a special partition called the EFI System Partition. This partition stores bootloader files in a structured and readable format. When UEFI starts, it directly reads these bootloader files from the EFI partition and executes them. There is no need to depend on a tiny piece of code like in MBR. You can imagine GPT as a well-organized digital directory with backup copies. Even if one part gets damaged, the system can still recover boot information from another location. Once the bootloader is executed, whether it came from an MBR system or a GPT system, its job is to load the operating system kernel into RAM. The kernel is the core of the operating system. As discussed earlier in this module, it is responsible for managing hardware, memory, processes, and system resources. After the kernel is loaded, the operating system officially comes to life. The kernel starts initializing key components. It sets up memory management so programs can be loaded safely. It prepares process management so multiple programs can run at the same time. It also loads device drivers, which help the OS communicate with hardware devices like disks, keyboards, displays, and network cards. For example, without the disk driver being loaded, the system would not be able to read files. Without the network driver, internet access would not work. All of this setup happens quietly in the background during booting Next, the operating system starts essential system services. These are background programs that support core functionality. Services related to security, networking, audio, and system logging begin running at this stage. Once system services are active, the operating system prepares the user environment. This is when you see the login screen. After you enter your credentials, the system loads your user profile, desktop settings, and startup applications. At this point, the booting process is complete. The system is fully operational and ready to accept user commands. It is also useful to know that there are different types of booting. A cold boot happens when the system starts from a completely powered off state. A warm boot happens when the system restarts without being fully shut down, such as after clicking restart. The steps are similar, but some hardware checks may be skipped in a warm boot. Understanding the booting process connects many concepts you will learn later. For example, when studying kernel versus shell, it becomes clear that the kernel starts first and the shell appears later as a user interface. When learning about file systems, you will understand why the system must mount disks after booting. When studying device drivers and interrupts, you will remember that drivers are initialized during boot time. In simple terms, booting is a journey from raw hardware to a usable operating system. Whether the system uses BIOS or UEFI, the goal is the same. Load the operating system safely, initialize resources, and hand control to the user. This process may take only a few seconds, but it is one of the most important foundations of how computers work. That is it for this video. See you in the next one.